Okay, guys. So today we're gonna talk about the integumentary system. The integumentary system is very important because it is the front line of okay. So this integumentary system is the system of the integument. So this integument is another way of saying the skin. So you say my skin or my integument. And this is a very high yield system because okay, this is a very high yield system because it is responsible for being the frontier of our immune system. So our immune system is divided into innate immunity and adaptive immunity. And this innate immunity is the natural immunity, the fence. So your home, before you having inside your home some weapons to defend you, a taser or a weapon that defends you against a foreign, dangerous criminal invader, or you having to call the cops and the cops come to your rescue, you had a fence around the house. You had the doors, you had the locks. So your integumentary system is very important for two things. For heat regulation, and that is the first essential concept. Whenever we want to explain homeostasis, we always resort to that hyperthermia and hypothermia example, and how we restore hyperthermia and hypothermia, and how these blood vessels that are shunting the blood to the periphery of our skin. So that's an example of how your integumentary system, how your skin is able to play a very important part in heat regulation. That's why burns are very dangerous, because these burns, if we do not perform grafts and we do not replace them with tissue that will heal and regenerate, we will have disturbances in blood volume. We will suffer from hypovolemia, and we will suffer from heat disturbance. That heat disturbance is going to exacerbate to becoming a form of a physical stress. So hyperthermia and hypothermia are forms of physical stress. The second thing your immune system is responsible for, that your skin and integumentary system is responsible for, is defense. It's defense. That's the barrier. The cells are so interlocking together with gap junctions and tight junctions. They disallow for the passage of dangerous pathogens that will seep through and destroy the tissue. Not only that, your skin is not just like a bunch of blocks that are put together that prevent the passage of some dangerous foreign molecule or invader. Your skin has resident sentinel immune cells, like police precinct. They are there and they are always performing surveillance in the nearby tissue. Is there a form of necrosis? Is there a form of infection? Then themselves, these resident sentinel macrophages, they will start to fight, and they will call immune cells that are secreting in the blood to migrate to the site on your skin, on your epithelial tissue, the site where there is a lot of damage and where there's infectious stress that needs to be repaired. So you have built in in your skin, you have built-in vesicles, you have built-in immune cells that fight and ensure that this tissue is stabilized. What about the glands? There is a lot of very important glands. Obviously, glands that secrete the sweat to help us with thermal regulation, ensuring that we have the proper internal core temperature and we do not suffer from hyper or hypothermia. We suffer from, we only enjoy euthermia. When it's cold, your skin is attached to skeletal muscle. Your skin is not skeletal tissue. Remember, we said we have four types of tissue. There's bone tissue, there is the connective tissue, there's epithelial tissue, and nerve tissue. Your skin is not a form of muscular tissue. It is a form of what kind of tissue? The skin. That's epithelial tissue. Epithelial tissue. That epithelial tissue is so tightly connected to the muscular tissue for two reasons. Number one, shivering thermogenesis. So your skin is not shivering. It is the underlying skeletal muscle tissue layer. That is the one who is excitable. Remember, epithelial tissue is not excitable. It is the nervous tissue that is excitable. It is that skeletal tissue that's excitable, and that is what causes your skin to vibrate. That's number one. Number two, for social interactions. If you look at the face of a human being, you can tell if the human being is happy, sad, content, angry. But if you look at a monkey, the monkey, you cannot read the face of a monkey. You cannot tell if the monkey is face, if he's sad or if he's happy or he's angry, because their epithelial tissue in their face does not have skeletal muscle. We have a lot of skeletal muscles. We have the orbicularis oculi around our eyes. We have the buccinator muscles around our oral cavity. That helps us have a beautiful smile. That helps us have the ability to display affection and the ability to display, emotions. But animals, they cannot have that, even though they are mammals like us. So you have to understand that this epithelial tissue of our skin is tightly intimate with the underlying layer that is skeletal muscle tissue. That's important for shivering thermogenesis to regulate temperature, and it's very important for social interactions. Why are our lips red? Why is this part red and this part is not? Yeah, excellent, because this area has a lot of capillaries, and that's why the blood is this reddish color is because of the capillaries being. So now that shows you there's vascular tissue nourishing the underlying basement membrane of these skeletal muscle tissues that are underneath our skins. And also the skin is very interesting because in your eyelid your skin is so thin, but in the shoulder blade your skin is so thick. So that means the skin is not uniform on every place in your body. So now you will see that the skin has different layers. The skin has the epidermis and it has the underlying layer, the dermis. And the skin is upside down. It grows from the bottom and then it migrates to the top. And we said there is a special quality. We talked about that in the tissue lecture, and that is exfoliation or desquamation. What does that mean? Exfoliation or desquamation. I'm sorry? Shedding, yeah. So now those cells, they grow up and then they die at the surface. So that means they start from the bottom and then they migrate their way up. Excellent, very good. And we've seen that this desquamation and this exfoliation does not happen in every particular type of tissue. We have tissues classified based on two things. Tissues classified based on the tissue type. Is it simple epithelium? Is it squamous epithelium? Is it pseudostratified? So I'm sorry, is it simple epithelium or is it stratified epithelium? or is it a gray area in between, pseudo-stratified? So that's the type of the tissue. Then we don't just label the tissue based on its type. Simple epithelium, squamous epithelium, or pseudo simple epithelium, stratified epithelium, or pseudostratified. That's the type. Then we move on to the next step, and that is the type of the or the shape of the cell. You can have simple columnar, simple cuboidal, and simple squamous. You can have stratified columnar, stratified cuboidal, and stratified squamous. So the skin is stratified squamous. So when we talked about simple epithelium, these were types of tissues that 100% of them are attached to the basement membrane. But the stratified, one layer is simple, but the rest are laying on top of each other. So we have, that is exactly what your skin look like. You have a layer of simple epithelium on top of which you have your stratified. And in addition to being stratified, the types of cells that give me this stratified squamous epithelium, these are squamous cells. Squamous cells are cells that have their nucleus at the surface, and that is like a egg sunny side up. So that is the cell that exfoliates and sheds. Your skin is very important in medical physical examination. Redness of the skin, erythema, inflammation of the skin, that redness. The heat, can feel the fever. Okay, so your skin is an important landmark reflecting the internal state, the internal health of your bodily system. Okay, cyanosis, bluish discoloration of the skin, is not red anymore. So that's not an inflammation. That is now caused by death due to the lack of oxygen supply. And now that could be also a problem with the nicotine. So when the patient smoke nicotine, that cigarette smoke is going to cause metabolic waste build up in the body. And this metabolic waste is going to prevent hemoglobin from unloading oxygen. You know, hemoglobin would go to the lung, load oxygen, would come to the tissue, unload the tissue who is so suffocating, needing oxygen. But if the patient smokes cigarette, the hemoglobin will have no problem going to the lung, getting the oxygen. But when he gets to the tissue, trying to give the tissue oxygen, the metabolic waste is going to prevent it from unloading that. So their body is full of oxygen, they just cannot get it to the tissue. Our skin tissue also has a lot of hair and has a lot of glands and sebaceous glands. And we said that there is an inequality with the thickness of our skin. So the soles of the palm and the associated fingertips and the soles of the feet and the toes, that's the thickest your skin will ever get. And then you can have very thin skin, and that is like in your eyelids. So those are really thin. Dermatology is the scientific study and medical treatment of the integumentary system. Okay, so the skin consists of the hair. So the integumentary system is a collective understanding of the skin, the hair, the nails, the associated glands, and the nerves that make up the integumentary system. So the skin or the integument is the body's largest and heaviest organ. It covers an area of about 1 to 2 meters squares, and that's the largest part. And it consists of two layers laying on top of each other. You have the epidermis And the epidermis is stratified. We agree to that. It's stratified. They are epithelial cells that are on top of each other, but they are squamous. So their nucleus is like an egg, sunny side up. And these are the cells that undergo the exfoliation and the desquamation. Right underneath, right below from the epidermis is the dermis. And that is the deeper connective tissue layer. So below the dermis is the hypodermis, and that is not part of the skin, but these are the subcutaneous tissue, but they are usually studied with the skin. So that shows us the epidermis, the outermost outer layer, and you have the dermis. On the dermis, you have the shaft of the hair cell and the bulb being anchored to that layer. And right beneath the dermis, you have your third layer all the way in the bottom, and that's your subcutaneous fat known as the hypodermis. So the skin thickness ranges from 0.5 to 6 millimeters. So the thickness range is mainly due to variation in the dermis thickness. But the skin is classified as thick or thin based on epidermis. So the thick skin covers the palms, the soles of the feet, and the corresponding surfaces of the fingers and the toes. And it has sweat glands, but no hair follicles or sebaceous oil glands. There are also the thin skin, and that covers the rest of the body. So it has hair follicles and sebaceous glands and sweat glands. Functions of the skin. So the functions of the skin are, number one is resistance to trauma and infection. And you know that keratin, that is your secondary structure protein. Keratin provides physical protection and it secretes dermacidins. These dermacidins and defensins are making up for us a type of chemical substance known as the acid mantle. And that is a very corrosive, very harmful layer of chemicals that destroys the invading microbes, including the bacteria and the parasites and the fungi and all of these, microbiota that is trying to harm our skin. But this dermacidin and defensin is not strong enough to destroy our own cells. It's just strong enough to destroy the cells of these uh, um, microorganisms. It is also the skin is a barrier to water, ultraviolet rays, and harmful chemicals. Now, when it comes to the association of the skin to the bone tissue, you know that the skin is responsible for vitamin D synthesis, and the skin carries out the first step in the genesis and the making of vitamin D. And if it wasn't for vitamin D, we can never be able to strengthen and thicken our bone matrix. Sensation. Our skin is innervated with a lot of nerves. That's why when you get a needle injection, you feel it right on the skin. But when it goes deeper into the muscle tissue, you're not going to feel that pain. So that reflects how the skin is full of nerves. And that's how the baby, when the mother is carrying the baby and rubbing on the body of the baby, that the baby is now feeling comfort and will be like so happy because the touch of the mom, then that will stimulate the stretch receptors on the surface of the skin of the baby. This is not just for the baby, it's also for adults. So the skin is very sensitive. And also, it's a double-edged sword because it's highly vascularized. That's why bruises happen a lot in the skin because we rupture the skins, because remember the skin is highly vascularized to nourish this tissue that's responsible for heat regulation, the tissue that is responsible for immune defense. It needs a lot of blood. So it's also susceptible to the bruising. Just a couple of days ago, my room was dark, so I tried to open the light and I hit that light switch and it bruised up my palm. So that area, even though it's the thickest, you see, it's the thickest. It was like a big bulb of like blood. It was just.
What, you just hit the switch?
Yeah, I got up and I thought the wall is a little farther, and it wasn't. So I just fell on the light switch, and I felt like something stabbed me. Then I opened, there was like a big balloon, red balloon. Yeah, yeah. I thought the wall was a little back. I'm an old man. Anyways, thermoregulation. So after the blood flow, um, so you really have to understand how the skin is responsible for heat regulation. That one is really important. And we're going to see this a lot when we deal with the nervous system. And we're going to see it with the endocrine system. And we're going to see it with reproduction. So I'm going to go over it one more time. So, your skin has a lot of blood vessels underneath. And we said that these blood vessels are in relationship with blood flow as follows. So the flow is directly proportional to the radius to the power of 4. So if I double my radius, if my radius was 1 centimeter, my flow would be 1. So 1 centimeter to the power of 4 is the same thing as 1. So that means my flow rate would be 1 milliliter per second. If I double my radius, so now my radius, let's say my radius was 1 centimeter, that means my diameter is about 2 centimeters. The diameter is double the radius. Now, if I double my radius, so now I have 2. 2 to the power of 4 is 2 times 2 times 2 times 2. That's 16 times. Just by doubling the radius, my blood flow increased not twice, 16 times. Same thing, drop. If I drop my radius from 1 into a half to the power of 4, that is 1 to the power of 16. So that means I drop my flow rate to 1/16. Amazing how the flow rate changes by modulating this diameter of my blood vessel. So when I'm suffering from hyperthermia, it is so hot, plus, it is so hot, hyperthermia. Now I need to dissipate that heat, dissipate that heat. What happens is I have to increase my blood vessel diameter, and when I increase my blood vessel diameter, the blood is going to dissipate. It's going to dissipate. It's going to dissipate. And the heat is going to go out from an area of a high concentration to an area of a low concentration. The opposite. If I'm now suffering from hypothermia, if I'm suffering from hypothermia, my diameter is going to now drop because my radius is going to drop a lot. My radius is going to drop severely, and when my radius drops, my blood flow is going to drop a lot, and it's going to drop by the rate of 1/16, and that means less blood is going to flow out because I'm sequestering the heat inside, and there is less blood flowing to the periphery. That means less heat is flowing, so I'm going to conserve my heat. And that is how, if it wasn't for your skin, this can never happen. And as we said, the skin is important for nonverbal communication. Try to read the face. So The medical doctors, the human medical doctors are um, different from the veterinarian veterinarians. Why? Because you can read the face of your patient, and there's always in the history taking as a nurse, you will see that there is a section known as your psychological section. You will assess the psychological, mental state of your patient. The veterinarian can never do that. He can never assess the psychological state of a monkey. The veterinarian. The veterinarian. Veterinarian. Okay, so that guy, he will have a problem trying to read the face of a cat or a sheep. He cannot do that, but you can. So skin is very important for verbal. I have two problems: saying veterinarian and embryological. Embryological. Okay. Oh, you see? You see? Now I can read this patient's face. That looks like what? Contempt? You know, women are better in understanding facial expressions than men. What is that? Yeah, that's true actually. She's annoyed? Okay. Try asking Joris and Sherwin and on us, what is that? I have no idea what that is. She looks content.
Like somebody told her no.
Hmm?
It's like somebody told her no.
Somebody told her what?
No. Absolutely.
Somebody told her nose?
No. Like if you want something and they say no.
Oh. Told her no. Yeah. Yeah. Yeah, I have no idea what that is, but I don't even know what this monkey now. Can you tell what the monkey wants? Can you tell at this day? You cannot. So that shows you. Yes, see the skin. He looks like he want to do something wicked. But that's how all monkeys are. Anyways, and you have to understand the structure of your skin. They are keratinized, stratified squamous epithelium, and it includes dead cells at the skin surface, and they are packed with tough keratin protein. Avascular. The avascular tissue, so the epidermis is avascular because it lacks blood vessels, and it depends on the diffusion of nutrients from the underlying connective tissue. So it contains sparse nerve endings for touch and pain. Cells of the epidermis. There are 5 types. There are 5 types of cells in the epidermis. There are the keratinocytes, and these are great majority. These are the great majority of epidermal cells, and they synthesize keratin. Stem cells. Stem cells are undifferentiated cells that give rise to keratinocytes. In the deepest layer of the epidermis is known as the stratum basale. I don't remember if I asked that on the exam, but this is really, yeah, this is really important to know where the stem cells are, the progenitors for your skin system. So you got to know they are in the stratum basale. Okay? Melanocytes. These synthesize pigment melanin that shields the DNA from the ultraviolet radiation. So that's the job of the melanocytes. And that's why in Africa, because the sun hits Africa straight in the equator. So that region, that's exactly where my country is. My country has the hottest, along with to the western part, with Chad, Sudan and Chad. That's the hottest place in the world. That's why we have really dark skin.
Yeah.
Really dark skin, yeah.
Yeah.
Not me, I'm not, because some of my family, they are not, like, it's a mix, but in Sudan you see a lot of really, really dark skin. And that is because the melanin is secreted to shield and protect your DNA. It's like a sunscreen. It's like putting sunscreen on your DNA. It synthesizes the pigment melanin that shields DNA from the ultraviolet radiation. That's actually this really hot. is actually something good because that can be used for like solar energy and it can be used. So that's a very good thing.
It's not that bad. It's 105 today.
Where?
Sudan.
In Sudan, yeah. Yeah, it was so hot. I went into the yeah, my iPhone would go off. Yeah, yeah, my iPhone would just go off. It says so hot, the iPhone would shut down. I went for my deodorant, it was water, it was all melted. That's how hot it was. It was so hot. And people over there chilling and they're wearing like robes and they were dressed in layers. Yeah. And women wearing all black and like shield with, and they're just walking, laughing in the street. And I'm like, oh my God, what is this? I used to live there 20 years ago, but when I went now, I was like, what is that? I was like a Caucasian with my. Yeah, that's how you do. Not supposed to turn back on your people. Okay. Do not be like B. Diddy. Okay. The melanocytes occur only in the stratum basale, but they have branched processes. So this stratum basale is high yield because it's home to the stem cells and to the melanocytes. So there are 5 epidermal cell types. Continuing with that. And so in addition to the melanocytes and the stem cells and the keratinocytes, keratin is what kind of protein? This is so important. So we said primary. Did I tell you guys about the Christian Anderson experiment? Oh no, that's a very big one. So the Christian Anderson experiment is the most important experiment in the biochemistry because he discovered that, obviously proteins come out. We talked about this in genetic expression. We said that the polypeptide comes out of the ribosome as a primary sequence, beads on a string. Then they fold upon each other. They fold and they make alpha helix and beta, and beta pleated sheets. So they can either be beta pleated sheets and alpha helix Then there's a tertiary layer, and that tertiary layer is when you have more extensive. So how do we go from primary beads on a string into alpha helix and beta sheet secondary structure? And that was caused by hydrogen bonding in addition to hydrophobic effects. Okay, in addition to, then we do more extensive hydrogen bonding, and more extensive hydrophobic effect, and more extensive disulfide bridges, as well as salt bridges, and that carries us over to the quaternary structure, and that is, in addition to that, we will have ionic bonding, Then we have a quaternary structure, quaternary structure. Okay, so keratin and collagen, where are they? Are they primary? Keratin and collagen, they are here, that's secondary. So keratin and collagen are secondary, while the tertiary are Myoglobin is tertiary. Myoglobin is tertiary. And lastly, hemoglobin is quaternary. So keratin is secondary. So what did Christian Anfinsen do? Christian Anfinsen, he added pH. He changed the pH. He added an acid. He increased the temperature. He added detergents. So these guys, they destroy what? Do they destroy the peptide bond? These beads on a string, they're connected by what? They're connected by peptide bond. They're connected by peptide bonds. They are connected by peptide bonds. These peptide bonds are later on, I'm going to add these additional bonding, hydrogen bonding, hydrophobic effects, van der Waals, disulfide bridges, salt bridges. But when I add these new bonds, am I going to lose the peptide bond? When I add these hydrogen bonding, no. And do they go away? They don't go away, they're still there. So what happened was he added urea, mercaptoethanol, he changed the temperature. So these guys started to fall back, denature. So if you go from primary, fold up to secondary, fold up to tertiary, fold up to quaternary, that is known as folding. That is known as folding. But if you start falling backward, that is known as denaturing. Denaturing. That is known as denaturing. But you can only denature as far as getting to the peptide bond. You can never break the peptide bond. pH cannot change the peptide bond. Salt cannot change the peptide bond. Temperature cannot change the peptide bond unless it's really, really crazily hot. Like an oven, then it will destroy it. So what he did was he brought a quaternary structure protein and a secondary structure protein and a primary structure secondary structure protein, and he disturbed all of these weak bonds, disulfide bridges, by adding mercaptoethanol that would break the disulfide bridge, change the pH to break the salt bridges, break the hydrogen bonds, and he realized that they all fell back to the primary structure. Then he realized when he restored everything back to normal. So now no more detergent, no more pH change, no more temperature change. What do you think happened? Exactly. So the process started building up and renaturing. Started from denaturing when you fall backward. Now started to renature and it went back into the quaternary structure. So when you restore the optimal conditions, you restore the weak bonds upon which the folding is dependent. And if you destroy them, you destroy the weak bond. So he realized that it is the primary sequence, that's the manuscript. The primary sequence is the main script that really tells what kind of, what is the protein going to be. But you got to know, keratin, secondary, myoglobin, tertiary, hemoglobin, quaternary. What's the difference between hemoglobin and myoglobin? Excellent. So hemoglobin is storage molecule, oxygen storage molecule, while hemoglobin is a delivery. It delivers the oxygen. Excellent. Very good. And what's the structure of myoglobin and hemoglobin? So tell it to me. Yeah. If you answered that question, you would have gotten extra credit for. I was waiting for you to say it. So because you remember this one is for storage, and this one is for. So that's the function. Remember, anatomy and physiology, we study structure and function. So I asked you how are they different. So you responded by answering the function. So one is good for storage, and one is good for delivery. Then I was waiting for you to say the structure. One is tertiary and one is quaternary. And now you would have gotten 5 points on the next exam. Wow. Okay, it depends because sometimes I ask like a really wicked question that is not on the slide, but I said it in lecture, and then you had to, like, she's good, she remembered it, but she just it just 1 second.
Yeah, but it's just like that.
Doesn't matter. Okay, tactile. So tactile is a touch receptor cells that are associated with dermal nerve fibers. These are tactile disc, and so the tactile disc is a collective term for tactile cell associated with a nerve fiber. So tactile meaning like touch. It senses. You feel like a sensation, and it carries this mechanoreceptor. How does that happen? So the gate channels, remember we talked about gate channels? These gate channels, they're not leak channels. Leak channels are open all the time. Gate channels open upon stimulation. Some of them open due to heat stimulation. Others open due to ligand binding stimulation, like acetylcholine. And others bind to open because of mechanical stimulation. So these tactile cells, they allow for the passage of ion influx through them or efflux based on the touch. So when you are touched, they open up, allowing for ionic exchange, and that causes voltage change in the membrane, and that is going to relay a signal of sensation. So if you touch this arm, if you shake somebody's hand with the right arm, you're going to feel it on the right hand, but not on the left, because the tactile receptors are stimulated based on the touch of the right hand, and they open, and all the ions are going to influx. Okay, so that shows you you see the exfoliating cells? I'm pointing to them with the mouse. They are the ones that are falling apart. And that is a sweat pore. And you have a sweat duct. This is a sweat duct. And these are dead keratinocytes. So what are the cells of the epidermis? The cells of the epidermis are arranged in 4 to 5 zones or strata. They are listed here from superficial to deep. So you have the stratum basale, and there's a single layer of stem cells and the keratinocytes resting on the basement membrane. And they also contain scattered melanocytes and tactile cells. There's stratum spinosum. Stratum spinosum is severe layers of living keratinocytes joined by desmosomes and tight junctions. They are named for the appearance of the cells after the histological preparation. There is a stratum granulosum. Stratum granulosum. These are 3 to 5 layers of flat, living keratinocytes, and the cells contain dark staining, um, known as keratohyalin granules. Layers of the epidermis. So layers of the epidermis are, you would have the stratum lucidum, and these are thin, pale layers that are found only in the thick skin, and there are keratinocytes that are packed with clear protein known as eledin. There's a stratum corneum, and these are up to 30 layers of dead scaly keratinized cells, and they resist the abrasion and penetration and the water loss. So the exfoliation happens at the top keratinized layer, and that is known as the dander or dandruff. Okay. So the epidermal layer also constitutes an epidermal water barrier because it's formed from processes above as well as tight junctions between the keratinocytes, and they help prevent dehydration, and they help prevent the loss of water. They prevent the seeping of water away from the intracellular compartment, from the interstitial compartment, from the extracellular compartment also into the outside of the body. They prevent the leakage. Then right beneath the epidermis is actually the dermis. The dermis is connective tissue layer, 0.2 to 4 millimeters thick. It is composed mainly of collagen, and it also contains elastic and reticular fibers. They are well supplied with blood vessels, sweat glands, sebaceous glands, and nerve endings. They are wavy, conspicuous. They have a wavy, conspicuous boundary between the dermis and epidermis, and that is known as the dermal epidermal junction. Dermal epidermal junction. I'm sorry. Okay, so beneath the epidermis is the dermis, and it is made up, as we said, of a wavy conspicuous boundary, and the dermal papilla are upward finger-like extensions of the dermis, and the epidermal ridges are downward waves of the epidermis. So the dermis consists of two zones. There's the papillary layer and the reticular layer. So that shows us our papillary layer of the dermis, and that is the reticular layer of the dermis, and both are below the dermal epidermal junction. The hypodermis represents the subcutaneous tissue layer. It is a subcutaneous layer of connective tissue that is between the skin, that is beneath the skin, and it contains more areolar and adipose tissue than the dermis. And it pads the body and binds the skin to the underlying tissues. So it is a common site of drug injection due to many blood vessels. And there's subcutaneous fat, and it refers to the subcutaneous tissue that is comprised predominantly of adipose tissue. So there is an energy reservoir, thermal insulation, and it is thicker in women, thinner in infants and the elderly. Okay, skin grafts. Skin grafts are a third-degree grafts, and the autograft, they are a tissue from another location on the same person's body. The allograft is a form of a tissue from an unrelated person that is usually deceased donor. There is an artificial, and so there is autograft and there's allograft, and there is xenograft. What's the difference between autograft, allograft, and xenograft? Autograft is from you to you, from your buttock to your arm that has been burned. Allograft is from a dead person to you. What is xenograft? XE, xenograft. Okay, so allograft is from you to you. I'm sorry, allograft is from another person to you. Auto is yourself. It's from you to you. What is xenograft? What did you say? An animal, exactly. Exactly, animal. Excellent. Very good. And your name is? Okay, good. So now you're gonna get 1 point. That's good. Did you guess that or you knew it already? You knew it already. So no point then. I thought like You derived it. Okay, 1 point. I don't go back. I'm not going back, but excellent. Very good, actually. Yes.
From the placenta. Placenta.
A graft from the placenta.
Yes.
The
They do
pla
that then.
Do they do that now?
Yes, they do that then.
I have no idea about that. But I would call it autograft because if it's your placenta,
Somebody else.
if somebody else is allo. So if anything coming from you to you, that's auto. If it's somebody else's who is the same species as you, but if you're getting it from the placenta of the monkey, then that is xenograft.
Human.
Yeah. So what did they graft it on then?
Somebody was burned and we grafted on her face.
Oh wow.
Yeah, badly burned, terribly burned, and yeah, it did. But with the placenta, it was so amazing. Her face was, yeah, amazing.
Oh wow. Wow.
Yeah, somebody else.
You know, people are very concerned with their skin and their face. You know, some people they will never leave the house without looking in the mirror. I'm not one of them, but you know, there's a lot of them. I mean, I brush my beard as I'm walking outside. My little nephew, he took my brush and he wanted to brush his beard, and he's 2 years old. Okay, so yeah, the skin is a major thing. I mean, it has a lot to do with self-image and social image. What's the difference between social image and social image? Self-image and social image. What's the difference between self-image and social image?
Setting a template and social.
So social image is how people perceive you, view you. Okay, people say, "Oh, that person he dress up like a bum." Now that's his social image. But you have another person who's he dressed like a bum, but himself he's not bothered. He doesn't care. So his self-image is intact.
Yeah.
But you have another person that the people they're really not. They don't care. He wears suit all the time. People don't care. But in his self-image, he thinks that he's fine. Or maybe some people, especially in patients who have obesity, patients who have obesity have very low self-esteem. Most of the patients because they believe that their body is deranged and deformed. So they always have like a distorted self-image and also social self-image due to the bullying, especially in like the younger population of teenage obesity and all of that stuff. So there's always the image, how you project yourself to yourself and how you project yourself to the society. That's very important. So that's why like the skin is the industry is making there's like a lot of industries based on how you look and how you project yourself. And this cream is anti-acne. This is the cream is anti that. And now a lot of people are paying money to scammers on Facebook telling them, use this, it will make this go away. And then mix this with that, it's gonna make whatever go away. And that's not true. So the we have to have a moderate care of the skin. That's not excessive. That is not like your budget for skin care should not exceed like a certain amount. Yeah, some people they spend like all their money on how they look. Okay, skin color. So people of different color have the same number of melanocytes, but the problem is the amount that is being secreted is not the same. So darker skin, their melanocytes produce greater quantities of melanin. So the melanin breaks down more slowly. So now, can you hypothesize that skin cancer is less prevalent among really dark skinned individuals? That sounds like an excellent hypothesis because we said that the melanin is like those shades. It shades the DNA from ultraviolet radiation. So now we want to study and see, is it really that? Because if people who have a darker skin have a lower skin cancer, then that supports our hypothesis. Lighter skin. In lighter skin, the melanin is clumped near the keratinocyte nucleus, and there's little melanin seen beyond the stratum basale. So these are variations in skin pigmentation. We talked about cyanosis. Cyanosis is the blueness that is due to the oxygen deficiency, and erythema. Erythema is like when you have excessive redness due to the increased blood flow to the skin, and paler. And there's paleness due to decreased blood flow to the skin. Albinism is white skin due to genetic lack of melanin. So these patients can never create melanin. So now another hypothesis would be there is a lot of skin cancer prevalent among patients of albinism because they don't have the genesis of melanin. Jaundice is the yellowish pathological discoloration of the sclera and the skin, sclera of the eye becomes yellowish, and it can be produced by compromised liver function. So the metabolic byproducts of breakdown of hemoglobin, if you have excessive amount, they will start to build up in the blood. And actually, some disease known as kernicterus is when you have a metabolic toxic buildup of this substance that is a heme byproduct, bilirubin, in the brain, and that causes some nervous and brain damage. That's known as kernicterus. You see, that's kernicterus. And this is, what is this? Excellent, excellent, excellent. Oh, you guys are excellent inspectors. Especially this one. This one was tricky. The other class, they had no idea what that is. They just thought that's a white baby. But no, that's a baby suffering from albinism. How did I know it was albinism? It wasn't a skin color. The hair, the eye is pink. Why do you think the hair is albinism? It's too whitish? I didn't know. I thought some people have this white hair. Oh, really?
Yeah, that's like gray hair, like when you get old.
Oh, wow. Did I tell you guys about the story of the a woman in South Africa who was killed because she was accused of cheating with a white man because the baby was albinism? Yeah. Okay, you gotta protect yourself from ignorance at all costs. If you are in an ignorant society, you may want to go somewhere else because that may lead to your death at some point. She did everything. She tried to prove she was a faithful woman. They would never listen to her. Yeah, no DNA. They have no DNA. So yeah, in my country, they used to call those children who are albino. I mean, that's ignorant too, but at least it's a little better. I mean, it's not like we're not gonna kill the woman, but what we do in my country is that we call these children the sons of the angels or something like that. The sons of the heaven. Yeah, they call them the sons of the heaven because they're so white. Is that's a little bit of ignorance than that one? Is not? It's no, it's not that you hate yourself. They didn't say they are better, but they just assume that because of this albinism, they are so white, they think that they are like the heaven or something like that. Yeah. Okay. Friction ridges are important because they help us have a better grip of things. These are markings on the fingertips that leave oily fingerprints. So everyone has a unique pattern formed during fetal development. And the flexion lines or the flexion creases These are lines on the flexor surfaces of the digits and palms and the wrist. The mole and the freckle and the hemangiomas, these are all types of aggregates that happen on our skin. So the freckles are flat melanized patches, and the moles are elevated mineralized patches that are often that often have hair, and they must be watched. They must be watched closely for changes. So a good example of an exam question would be, which of those three must be inspected in close um, proximity to ensure that it is not cancer. But if it will never be cancer if it's benign. But cancer tissue look in the beginning like a mole, but then it will become something else. But a mole is a benign form of a tumor. Okay.